In section 6.4, we're going to talk about similarity in right triangles. So it's really no different than what we've been talking about before. We're going to talk about how corresponding sides are in proportion, but very specifically, we're going to be talking about right triangles here. Okay, so the altitude drawn to the hypotenuse of a right triangle divides the triangle into two triangles that are similar to the original triangle and to each other. Okay, so you're going to see a picture of what that means in just a second. So we want to write a similarity statement relating the three triangles in the picture. Okay, and that really is the first question, is how many triangles are in this picture right here? And the answer is there are three. And I highlighted those three in different colors on the right. Okay, so we have the red triangle, the blue triangle, and the pink triangle. And now we want to know, are they similar to each other and why? Yes, they're similar to each other because they share two angles. Each triangle is going to share two angles. So they're similar by angle. Okay, so then what I did, going from that picture on the right, I pulled them apart to get my three individual triangles. Okay, so again, if I want to write a similarity statement about these triangles, I'm going to say that triangle WYX is similar to triangle ZWX, which is similar to triangle ZYW. So if all those triangles are similar to each other, we can write proportions to relate their sides, because again, corresponding sides of similar figures are in proportion. They're going to form two fractions that equal to each other. But again, very specifically, when we're talking about a right triangle that looks like this one above, okay, if the altitude is drawn to the hypotenuse of a right triangle, then here's my corresponding sides, all in proportion. There's going to be three different ones that I can say. I'm going to say, again, that the altitude over segment 1 is going to equal segment 2 over the altitude. I can say leg 1 over segment 1 equals the hypotenuse over leg 1, or I can say leg 2 over segment 2 equals the hypotenuse over leg 2. So again, leg 1 is just going to be this piece of the triangle here, which in that picture would be AB. Leg 2 would be the other side of that full triangle, which in this case would be BC. Segment 1 is just AD. Segment 2 would be DC. And if I put segment 1 and segment 2 together, I'm going to get the entire hypotenuse of that big triangle. And again, my altitude is this red segment going down the middle here. Okay, so in a non-pandemic year, yes, you need to know all of those proportions. But again, if you ever forget them, you can pull the triangles apart like we did up there and come up with your own proportions. It's just hard to see. It's better if you actually know the three. But again, if it's me, I'm going to keep these three very handy and this picture right here. So you can even redraw the picture, whatever you want, but somehow this is going to be very important. Okay, so the first thing that we want to do in number 2 is we want to find X and Y in simplest radical form. Okay, so since this is the first example that we're doing, I'm just going to label what my leg 1, leg 2, segment 1, segment 2, all that stuff is, just so you can see it all. It's the only time I'm going to do it though. Okay, so this would be leg 1. This would be leg 2. This would be my altitude. This piece is segment 1. This would be segment 2. And this entire thing is going to be my hypotenuse. Okay, so first I want to find X. Okay, and notice X was the one that was labeled with the altitude. So if I go back to my proportions from the last slide, there's only one proportion that has the altitude in it, and it's that first one. So we're going to do the altitude over segment 1 is going to equal segment 2 over the altitude. Okay, so looking at this picture, again, our altitude is X, segment 1 is 24, segment 2 is 6, and again, my altitude is X. And now we're going to cross multiply and solve. So X times X should give me X squared, and 24 times 6 is 144. The opposite of squaring something is going to be to take the square root. And when I take the square root of both sides, this time 144 is a perfect square, so we're not going to leave it in radical form. We're going to take that square root, and X is going to give me an answer of 12. Okay, so the next thing that I want to find is Y. Okay, and Y is the one that's labeled leg 2. So again, if I go back to the three proportions on the last slide, there's only one that has leg 2 in it. It's the third proportion on that previous slide. So to find leg 2, we're going to do leg 2 over segment 2, and that's going to equal our hypotenuse over leg 2 again. Okay, so again, leg 2 from the picture is y. Segment 2 in this case is 6. And now our hypotenuse. Our hypotenuse is the entire side here. So I'm going to have to add 24 and 6 together for an answer of 30. And again, leg 2 is y. So again, I'm going to cross multiply and solve. So y times y is going to give me y squared. And 6 times 30 is going to give me 180. Opposite of squaring something is taking the square root, but this time 180 is not a perfect square. So again, the directions say in simplest radical form. So what I want to do now is I want to find the biggest perfect square that's a factor of 180. This is from way back when. Remember, it's just going to keep coming up every so often. The biggest perfect square that's a factor of 180 is going to be 36. And if I take 180 and divide it by 36, I'm going to get an answer of 5. So it's going to break down into radical 36 times radical 5. And now I know what the square root of 36 is. It's 6. Okay, and then I'm going to tack on the radical 5. So in simplest radical form, your answer is going to be 6 radical 5. It seems like we're missing a picture here. Okay, so the triangle ABC is a right triangle with CD and the altitude drawn to the hypotenuse AB. If AC equals 20 and AB equals 25, we want to find the 4 things here. Okay, so first let's draw ourselves a picture. So there's a picture. Okay, and this should be a right angle, and I'm going to call this A, C, B. And my altitude is going to drop down here, and that is going to be D. Okay, so again, let's go back up and to the top, and it tells me that AB is 25. So this piece is going to be 25, and AC is 20. And I think those are the only 2 pieces of information that I was given. Yeah. Okay, and now I want to find 4 things all together here. Okay, so it doesn't matter what we do first. Let's do it in the order that it's given. So let's find AD first. So I'm going to call AD X. Okay, so I am going to write again just one more time. I said I wasn't going to do it, but I'm going to do it. That's leg 1. Leg 2, because if you do it this way on your paper, then I think you'll get the answers a lot easier if you keep labeling your triangles all the time. Okay, so it might be a good idea to do that. Okay, so AD we just called X. So X again is segment 1. So if I go back to my proportions and I look at them, there are 2 different proportions that involve leg 1, but since I don't know anything about the altitude here, I'm actually missing that one too. I can't use the one with the altitude in it. So I'm going to do the one that has leg 1 over segment 1, and that's going to equal my hypotenuse over leg 1. Okay, so leg 1 is 20, segment 1 is X, the hypotenuse is 25, and leg 1 is 20 again. Cross multiply. When I do that, X times 25 will give me 25X, and 20 times 20 is 400. And when I divide both sides by 25, X is going to equal 16. Okay, and that's really AD. So AD is going to equal 16 here. Okay, so I'm going to go in and I'll erase the X, change my color since I just found it. So now that is 16. All right, so now let's do part B. Okay, so we did A. Now I need part B. I need to find DB. So DB is, change to orange. DB is this piece here that I just put that orange X in. And now I have something about segment 2. Okay, so again, the one that I am going to do here, I don't actually even have to set up a proportion in this one. I can, but why bother? We just found this piece was 16. I know the entire hypotenuse is 25. So if I take 25 and subtract 16 out, that's going to give me an answer of 9. So dB here is going to equal 9 just by a simple subtraction. Again, I could set up a proportion, but why bother? Okay, so again, I'll put that in now in red since we have that one. So now we know that that is 9. Okay, so now we're on to part C. So we want to find CD. Okay, so CD is the one that I just put another X in now. Okay, and that's your altitude. So again, there's only one proportion that deals with the altitude. So we're going to do the altitude over segment 1 equals segment 2 over the altitude. Okay, so again, my altitude here is X. Segment 1 is 16. On the right, segment 2 is going to be 9, and my altitude again is X. Cross multiply, X times X is X squared. 16 times 9 is 144. And again, when we take the square root of both sides, my altitude there, or the length of CD, is going to be 12. So now this one is 12, so we'll get rid of the X up there. Okay, and I think I'm finally on to my last piece here for part D. I need to find BC. Okay, so BC is leg 2. So again, I'm going to do the one that has leg 2 over segment 2 equals the hypotenuse over segment 2. So I am going to have Z. I don't know why I just wrote Z. I called it X. Sorry. I'm going to have X over 9 is segment 2 equals my hypotenuse is 25. And again, segment 2 is X. Cross multiply and we'll solve again. So I'm going to have X times X is X squared. And 25 times 9 is going to equal 225. Again, the opposite of squaring something is to take the square root. And 225 is a perfect square. So when you take the square root of that, you're going to get an answer of 15. So leg 2 is going to be 15 there. Okay. And again, that is finding all the 4 things that we were asked to find. Okay, so again, we have another question here in the right triangle ABC. The altitude CD is drawn to the hypotenuse AB. Okay, so again, I need a right triangle. Okay, so there's my right angle. Okay, and it tells me that the altitude CD is drawn to the hypotenuse AB. So again, the hypotenuse is the side across in the right angle, which means that that has to be AB, which means that's C. So when I drop my altitude now, that's D. Hey, they tell me that CD is 12, and then it says AD exceeds DB by 7, and we want to find both DB and AB. Okay, so again, if AD exceeds DB by 7, we always have to let one thing be X. So since I'm comparing AD to DB, whatever you're comparing to is always going to be X. So since I was comparing AD to DB, DB is going to be X. Okay, AD exceeds that by 7. What does that mean? Exceeds, it's 7 more. Okay, so I'm going to do X plus 7 for AD. So there's my picture. And again, now I'm going to have to solve here. So again, if I want that color. If I go back and look, this is my altitude, and this is segment 1, and this is segment 2. Okay, so I'm going to do the very first one, the altitude, again, the top proportion if you scroll back. Altitude over segment 1 is going to equal segment 2 over the altitude. So our altitude here again is 12. Segment 1 is X plus 7. Segment 2 is X, and again, our altitude is 12. So now we're going to cross multiply. Okay, so again, please be careful. It's X times this entire thing. So it's going to be X times X plus 7. And 12 times 12 will give me 144. So the first thing I'm going to do is distribute X through the parentheses there. So I'm going to have X squared plus 7X, and that's going to equal 144. Okay, This is a blast from the past because we have not seen a question involving factoring all year. Okay, go way back to your algebra days. This is a quadratic equation. In order to solve it, I wanted to factor it. In order to factor it, it needs to be set equal to 0. So the first thing I'm going to do is subtract 144 from both sides. Again, on that left-hand side, there are no like terms. You can't actually subtract anything there. So you're going to have x squared plus 7x minus 144 equals 0. So now to factor a trinomial, again, going way back into your algebra days, you need to find two things that multiply to 144 and at this, or negative 144, and at the same time add to a positive 7. It's going to be a positive 16 and a negative 9. If you multiply 16 times negative 9, that's going to give you an answer of negative 144, which is what I wanted. And if you do positive 16 plus negative 9, you're going to get an answer of a positive 7. Okay, so it's going to be a positive 16 and a negative 9. All trinomials factor into two binomials. Okay, and again, the first thing that's going in there is x, and the next thing is the two numbers that we just found. So we're going to have a plus 16 and a minus 9, and that's going to equal 0. To solve that, we're going to set each factor equal to 0. So I'm going to have x plus 16 equals 0, or x minus 9 equals 0. On this one, we'll subtract 16 from both sides, and x is going to equal a negative 16. And on that right-hand one, we'll add 9 to both sides, and x is going to be equal to 9. Hey, I can't have two answers here. Hey, and one of the answers hopefully is pretty obvious which one that you should throw out. If we're talking about the length of the side of a triangle, hey, you can't have a negative length. So we're going to get rid of that negative 16. So I'm going to have x is 9, which means that segment 2 is 9, or DB is 9. But again, we also wanted to find AD. So again, if x was 9, I'm going to do 9 plus 7, and that should give me an answer of 16. So AD is 16 and DB is 9.